than in the world of tech. I mean, think about it. We're constantly pushing the limits of how fast our computers can process information, how quickly we can download movies, stream videos, you name it. And let's be honest, nobody likes waiting. Waiting for things to load, waiting for that buffer to finish. It's like the ultimate test of patience. But what if, and just hear me out here, what if we can make everything lightning fast? Like literally operating at the speed of light. Well, get this, there's a new technology on the horizon, and it's called a Programmable Photonic Latch, and it has the potential to absolutely revolutionize the way we store and access data. So to understand this, we got to take a step back and think about how our current computers work. They rely on electricity to move data around, right? All those ones and zeros zipping through circuits. But electricity has its limits. It generates heat. It encounters resistance. But light, now light is a whole different story. Light travels much, much faster than electricity, and it's incredibly efficient. And that's where this photonic latch comes in. It uses light instead of electricity to store and retrieve data. And we're not just talking about a little bit faster here. We're talking about speeds measured in tens of picoseconds. Now, I know what you're thinking, people call second. What even is that? Well, hold on to your hats, because a picosecond is 1/trillionth of a second. It's so fast, it's almost impossible to even comprehend. But speed isn't the only advantage here. This photonic latch is also incredibly scalable, meaning it can be used to build massive data storage systems. And it's compatible with existing silicon photonic processes, which is a fancy way of saying it's easier and cheaper to manufacture. So now that we've got the basics down, let's dive a little deeper and see how this thing actually works. So at the heart of this technology are these tiny components called silicon photonic microring modulators. Now, these micro-ring modulators act like tiny light switches, directing the flow of information encoded in those super-fast light signals. And by cleverly combining these modulators with optical universal logic gates, researchers have been able to create this photonic latch that can store and retrieve data using light. Now, the really exciting part is that they've already built a working prototype and demonstrated its capabilities in the lab. They've actually shown that this technology can perform those basic functions of data storage and retrieval at these incredible speeds we're talking about. So I know this is a lot to take in, but trust me when I say this is groundbreaking stuff. But it's not just about the technology itself. It's about what this technology can enable. It's about the possibilities it unlocks. So let's take a minute to explore some of those possibilities, shall we? Okay, so first let's talk about artificial intelligence, or AI as everyone's calling it these days. AI is already changing our world in so many ways, from self-driving cars to personalized medicine. But the thing about AI is that it's incredibly data hungry. I mean, these algorithms, they need to process mountains of information to learn and improve. And that takes time. But with this photonic latch, we could potentially speed up AI processing by orders of magnitude. Imagine AI systems that can learn and adapt in real time, making decisions and solving problems at lightning speed. It's like giving those AI brains a turbo boost. And the implications are mind-boggling. Now, let's shift gears for a second and talk about something a little closer to home. Our smartphones. Imagine a smartphone that can download a full-length HD movie in a fraction of a second, or a phone that can process complex image recognition tasks instantly, like identifying plants and animals, or translating text in real time. With photonic memory, these kinds of things wouldn't just be possible, they'd be commonplace. And it's not just about speed. Remember how I mentioned that light is incredibly efficient? Well, that means that our devices could become much more energy efficient too. Imagine a smartphone that can last for days or even weeks on a single charge, or a laptop that doesn't need a cooling fan because it generates almost no heat. These are just a few examples of how photonic memory could transform our everyday lives. But the real game changer here is the potential for entirely new applications that we haven't even thought of yet. Once you start talking about data processing speeds at the speed of light, the possibilities become almost limitless. So while it's still early days for this technology, I think it's safe to say that we're on the cusp of a new era in computing, an era where speed and efficiency are no longer the limiting factors, and where the only limit is our imagination. But, as with any powerful technology, there are also potential downsides that we need to be aware of. And I think it's important to have a frank and honest conversation about those as well. Because at the end of the day, technology is a tool. And like any tool, it can be used for good or for bad. So as we move forward into this exciting new world of photonic computing, let's make sure we're doing so with our eyes wide open, mindful of both the incredible possibilities and the potential pitfalls that lie ahead. I mean, think about it. If our computers can access and process information almost instantaneously, what does that mean for things like privacy? Could someone with malicious intent use this technology to gain unauthorized access to sensitive data? And how do we protect ourselves in a world where data breaches could happen at the speed of light? The future is not predetermined. It's up to us to shape it. And the choices we make today, the conversations we have now, will determine what that future looks like. So let's embrace the possibilities, but let's also proceed with caution, ensuring that this incredible technology serves humanity, not the other way around. Thanks for joining me on this deep dive. Until next time, keep exploring, keep questioning, and keep pushing the boundaries of what's possible.